record the session. Those who can stay, you can stay and participate in the lecture. So, right, hopefully others will also join. The important thing here that I would like to notice, bring to your attention is that, let me first of all prepare my desktop for the session. Where is it? Right. Okay, LMS module. P110 data wrangling. Okay. Right. Share my screen. Right. As you can see, and I hope you can hear me, please at least send a thumbs up or something so that I know you can hear me. Right. So, right, cool. Now you can see that I have uploaded 3 PDF files, one containing the reading material for Python for data wrangling. And I sort of thinking that I will be removing this part because this is a copyrighted material. I hope everybody could download this one, and I'll give you like this week perhaps to download this one. And then I am going to remove it because it's a copyrighted material, and it's not good to keep it on the Moodle. I have it, so I can share it with you, but unfortunately we cannot sort of do it physically. Therefore, I kept it on the repository of the Moratua LMS. You can download this one and then keep it with you. It's a part of this book called, I have cited the reference here, Introduction to Data Science Using Python. You can refer to the book. It contains a very good resource about data wrangling basic tasks in Python. And I'll keep it for your reference. And then I have uploaded the lecture slides as well. But here, mainly I referred the book, and I'm just giving you the basics of the initial parts of Python data wrangling tasks. So I kind of organize the things for you so that it is easy for you to follow, right? I'll start the lecture with this one. And on top of that, there is a Python exercise file. I have developed this one to match the lecture content, and I have sort of what do you call that, Python notebook here. So I will be running the example with you, but I'm not going to share this one with you because I know that some of you might not be following the instructions as I do, and I know that it's difficult. Therefore, I remove the outputs from the file, and I have created this PDF. So I want you to complete this task. I don't mind even if you copy this one and redo it, but I want you to do it in your computers and upload the exercise file to the Moodle. I'll create that upload link here as well. Right. So that's the basic intro to the lecture today. I want you to again highlight some of the things that that I want to convey to your batch. First thing is, when you go here, you can see there are 53 participants. Only 42 have submitted their ggplot exercise files. And then if you go to if you go to the project upload, only 45 of you have uploaded, and I've got 2 emails mentioning the difficulties. I will open the link. I will open the upload link here. So please tell your colleagues and your batchmates to upload this one and complete that one, because at the end of the day, you might lose marks when we finalize the marks. As you can already see, it's very difficult to convey that this is going to be marked or that is going to be marked upfront, given the situation that we might have to complete the entire continuous assessments in a very short span of time, or we might not. We have to divide the continuous assessments in a way that it will not affect the daily lives of students. As you can see there, it's not a normal time. There will be a lot of challenges and difficulties. We think of that, particularly I think of that. So I have divided the continuous assessments in a way that I give you the task to do, and as much as you can do it and upload it, because we will have at least 1 week of time. Then I will have enough material to mark for your continuous assessments. So that way you can also earn marks for the work. And of course, there will be tasks that I ask you to do without my intervention, and they will be quite challenging. So if you can uh, score marks for these things which are already there, and you just need to run this one and then upload the session as a PDF or something like that, that's pretty easy for you. And I think it will help you to understand the subject as well. Right, I'm going to start the lecture now. So data wrangling, we have done this one using R so far, and you have done the project as well. There are some parts that I would like to extend, particularly with R, particularly about the text analytics and web mining task. I thought of doing that one later, just to allow you to dissolve what is happening here. And then maybe by 21st of April, I'm thinking of doing the text analytics part using R. Now, for the time being, today's task is to learn about Python in data wrangling. So as you already know, data wrangling is the art of clearing out data in a way that you want your data to behave or appear while giving some easy ways of processing those data, right? So in this case as well, when we go to the why Python in data wrangling, compared to high performance production languages such as C or C++, prototyping languages such as Ruby, Perl, and Python can be viewed as multi-paradigm languages. So multi-paradigm languages means you can do several things apart from just developing software. So if you think about C, C++, C Sharp sort of things, you are focusing on product development, software product development. But in case of Ruby, Perl, and Python and similar prototyping languages, what you try to do is to use that language and maybe analyze data, maybe produce graphs, maybe keep databases and dashboards, online access dashboards, things like that. So these are multi-paradigm languages. You can look at the language, and there are multiple ways in which you can handle that language, and there are so many applications as well. So the codes can be executed immediately in the Python console without needing them to be compiled to machine language. So if you have worked with C++ or C, perhaps you have worked, if you have worked with C++ and C, you can say thumbs up. Have you worked, or otherwise thumbs down or something? At least another icon. Have you worked with C++ before? No, okay. So C++, you have to create you have to compile it. So once you write the code, you compile it, and the compiler will create a machine language file. So that machine language file can be executed. That file will be used, and then the program will execute. So there are three ways, like three files. First thing is coding, and then you have to get the compiler, and then the compiler will create a machine language file, and the machine computer will be executing that file. So if you are working with microcontrollers or simply computer languages, computer software, you are going to use C, C++ and these compilers. But in the case of Python, similar to R, but Python is a language. R is also a language, but they are different. There's a slight difference in them, because Python can be used to develop software as well, whereas R is used to do the statistical analysis mainly. So, right. So you don't need compiler, and the good thing is you just need the code to run on your uh, console, and then you will get the result immediately. So it's more like you do the programming part in the integrated development environment, and then you immediately get the results rather than compiling. And large ecosystem of scientific libraries and vibrant community is available for Python. So if you look at Stack Overflow, Stack Social, or all these ways, and also if you look at libraries, particularly Python has vast majority of libraries focusing on different scientific applications. So if you think about, for example, science, say you need visualization, or if you need video editing, all sorts of OpenCV sort of image processing, neural networks, deep learning, natural language processing. So even physics, you have this multi-physics optimization, and also simulations, signal processing, electrical engineering, civil engineering, and also data analyst jobs, and business database, web page design. You get a lot of things, and you get a lot of libraries built by the community. So they are not expensive. So because they are free and open source, you can integrate them readily to the environment, to the working environment, and to the project that you are working in. Therefore, that is a plus. And the second thing is, since it's a community software sort of a thing, it has a lot of people, like community. It has a great community. You can talk with the people. So you can ask those who are working uh, in this area, and then so many people will be there to help you. Therefore, it has a very vibrant community as well. That's why we typically, as data scientists, use Python, particularly in our work. So if you like, people used to say this one often, if you are going to do statistical analysis, it's very good to use R. If you are going to use data science approaches such as machine learning, neural networks, or deep learning, or image processing, it's good to use Python. So that's kind of the rule of the thumb. So it's very good to use both of them and learn both of them simultaneously, because it will help you in the future when you are developing as an analyst. Right. Now, I have developed the context why Python is important for this data analyst task. Now, there are so many libraries, as I told you, OpenCV for image processing and video processing, NLTK for natural language processing. There will be so many other, if you are familiar with this physics environment, you have YADE, you have signal analysis processing, and snow algorithms. So many algorithms and libraries are available. So we need to know what sort of libraries are needed for our work. So it's very important to understand what is needed rather than knowing the totality of the thing. So because when I know that some of you might be trying to learn computer science, data science using other channels, maybe reading blogs, maybe watching YouTube, or then other Coursera or some other sources. But when you do that, you will be overwhelmed by the sheer magnitude of information available. There will be so many articles about different libraries, different things, and different languages perhaps. So it's important to make it very simple and try to focus on what is needed. Now, in that case, when we are trying to learn data science using Python, there are four main libraries that are important, very important for data science, and in particular for this course, data wrangling. So what are they? The first one is NumPy. and second one is SciPy, and then Scikit-Learn and Pandas. So I have given the kind of the little phrase about them. NumPy provides a support for multidimensional array and basic operations and linear algebra functions. I believe that you have learned linear algebra by now. Can somebody say thumbs up? Have you learned linear algebra by now? Linear algebra contains vectors, partial differentiation, parts, and kernels. These things, I think you have learned that. It is in your early semesters. Have you learned it? Yes. Right. So NumPy provides the support of converting those data points, tables into multidimensional array. So what is a multidimensional array? If you look at NumPy icon, you can see there's an N, and there is like there are blue sort of squares, which indicates something like a Rubik cube. So multidimensional array means it's easy to understand two-dimensional array. If you look at a table, it's pretty much a two-dimensional array. Think that for the same table, you have another dimension, right? It's like when you think about in terms of vectors, it's like having two coordinates and three coordinates. So in the case of two coordinates, you have X and Y. So you can, on a piece of paper, if you draw a 2D Cartesian plane, you can draw a point using the X and Y coordinates, right? If you want to extend that to the 3D space, what you do is, what we do typically is we draw a 3-axis chart on a piece of paper, and you have an x-axis, y-axis, and a z-axis. That's it. That's on the paper. But if you think about on the 3D space, you can have, it's like a cube, right? So you have a cube, and you have three data points pointing at a certain location. So you can get the location of that. So that's a multi-dimensional array. That's a three-dimensional array. Right. When we extend from 3 dimension to 4 dimension, 5, 6, 7, etc., that's basically a set of coordinates. It's difficult to imagine because our brains are not used to imagine beyond 3 dimension, uh, 3-dimensional space. Some of them might be able to, but I'll give you an example. 4-dimensional space is like time. So if you have a cube with say that you have a Rubik cube. If you are familiar with Rubik cube, it is like a 9 by 9 thing. You can flip the sides and create those colors. So if you are familiar with that one, 4 dimension is like changing the color with time. So the intensity of the color can be like you have a very bright red and a medium red and then the low sort of red color. So that change with time, we can consider it's like a 4-dimensional space. So multi-dimensional array means you have this information about a particular location that goes beyond the 2-dimensional normal thing that we know. So NumPy gives you that chance to, because our brains are not able to comprehend, it gives us the chance to use the vector notation and convert that vector notation to this multidimensional array. So that's the first part about NumPy. Then we talk about SciPy. So SciPy provides a collection of numerical algorithms and domain-specific toolboxes, including optimization and statistics. So what is this numerical algorithms? So NumPy simply gives you the linear algebra functions, but SciPy gives you the ability to do the arithmetic operations. So it can be Newton-Raphson method, it can be Gaussian methods. So these calculations, numerical algorithms that can give you the results are calculated using this SciPy toolbox. It's SciPy library. So it can include optimization. So if you are familiar with this maximum and minimum, maxima and minima, partial differential equations, partial differentiation, giving you the peaks and routes. So these things can be calculated using SciPy numerical algorithms, which is very important if you are focusing on certain maxima, minima, certain differentials or certain variations, etc. When we go to Scikit-Learn, Scikit-Learn is a machine learning library built from NumPy, SciPy, and Matplotlib. So as I told you, it's like, imagine it's like our hand. If you think about our hand, you have 5 fingers, right? And then you have your palm and your wrist and then your elbow. All together, it's the arm. But as single entities, they can also work independently, right? Your fingers can move, your palm can hold something, and your elbow and wrist can bend. So they can individually function, and all together they are like the hand, like not like they are the hand, right? So similarly, Scikit-Learn is a machine learning library. It is built from NumPy, SciPy, and Matplotlib. So you can do the machine learning task using Scikit-Learn library, right? So the thing that I want to highlight you here, since you are going to carry on your machine learning journey, the NumPy, SciPy, and Matplotlib, they are also able to do this Scikit-Learn task, so machine learning task. But we are directly using the Scikit-Learn libraries in our work when you want to do machine learning, because some of the algorithms and libraries have been integrated to optimize and suit our need. Therefore, sometimes it's, even though it's not an abstract thing, it's a constitute of many other libraries. We use that library as a single library because it allows us to work on what we need. And when we think about pandas, pandas is one of the most important libraries in Python when it comes to machine learning and artificial neural networks and this data related work, because it allows us high performance data structures and data analysis, because it allows you to store data in data frames. That's the most important thing about pandas. It allows you to store data frames. Now since you have worked with R, you know that you can create a data frame, you can name the headings, and then you have data along columns, right? When it comes to multidimensional arrays, there will be snapshots along different levels and you will create many different data points or many different data sheets. When you call internally, these data frames need to be organized very efficiently. Otherwise, it will use a lot of computational power, right? So pandas allow you these high performance data structures and data analysis capabilities. Now, this is the story about all these 4 Python libraries and why they are important in our task, data science and any data analysis task. Right, now let's move to the next point. Now, it is beyond the scope of this course to talk about Python. I believe you have, Supun is doing principles of programming in semester, I think it is semester 1 or 2, I think. And you are learning data structures and algorithms in semester, I think data structures and algorithms are taught in semester 3 or something, I guess. So it is not the place to talk about Python or data structures and these things. Therefore, I just gave you the basic instructions to install the Anaconda Python distribution, because we are using Anaconda in this class. So in Anaconda environment, maybe some of you are already aware, in Anaconda, there are 2 ways that people use to do programming or these data analysis tasks. One is SPIDER, Scientific Python Development Environment, that is SPIDER. It's an integrated development environment known as IDE. So in an IDE, you will find editor, the compiler, or the debugger. So the compiler is not related to Python work. So interpreter is what we call it. And we have the debugger in Spider. So some of you might be happy working in Spider, and some of you might be happy working in the other one, that is Jupyter. So this is not Jupyter. It should have been called as Jupyter, because Jupiter, the planet, it has a different spelling. This is Jupyter, but it's easy to call Jupyter, and I also call it Jupyter because it's easy. So Jupyter as the web integrated development environment. So what we need to understand here is that Jupyter and Spider both can be used to do the coding, but as a teacher, as a lecturer, I prefer using Jupyter because it allows me to kind of easily compile things and give it to the students, so that with the comments and everything, it is more like a notebook. So that is easy for me to teach, but you are not limited to use just Jupyter or Spider. But for the convenience of this course, I request you to use Jupyter because it allows you to easily create PDF files for the submissions, and maybe LaTeX if you are familiar with LaTeX. So it is much convenient. Therefore, I request you to use Jupyter notebooks in the course for the convenience, but for your other work or any other place, you can use Spider. Right. Now, the Jupyter Notebook environment, you can open the Jupyter Notebook by simply typing Jupyter Notebook. So this is easy to work with in, let me open another terminal. So this is easy when you are working with MacBook or your Mac Pro or something using a Mac OS. You just need to type Jupyter Notebook. If I show you, just say Jupyter Notebook, it will work. For Windows users, I can't simply use my Windows machine right now because of the current issue. But for the what do you call for the Windows users, you can once you install the Anaconda, you will get something called I forgot that it's called prompt. It's like the shell prompt. It's something like CMD. Similar to CMD, you will get an Anaconda prompt. So on that Anaconda prompt, you can type Jupyter Notebook or simply Notebook, and it will give you the Anaconda Jupyter Notebook open. So the Jupyter Notebook platform started by clicking on the shortcut icon, but as people who are using Anaconda often, you don't need that. You can just type the above one or use the prompt to take the Jupyter Notebook on, because that will be helpful when we are developing environment variables, or installing certain libraries for certain analytics jobs. It will be very, very important to create environments. So it's good to know how to open Jupyter Notebooks using the other means rather than double clicking the icon. Okay, so that being said, right, so you can, once you have done this, I will talk about this importing NumPy, Pandas, Matplotlib, and etc. in a moment with the hands-on exercises. But all in all, as I told you, for the convenience of the course, I am using Jupyter Notebooks, and I ask you to use the Jupyter Notebooks as well, because it is easy to create the results like PDFs and all these things, right? So for those who have not used Jupyter Notebooks or are not familiar with Jupyter Notebooks, you can do once you have coded this thing, you can sort of play. If you click on this play icon here, run, it will compile, or it will execute this cell. And also you can shift enter, or for me, working with this one, I can type control enter or shift enter, also works for me in Mac. And cell for run as well. So run, you can do either of these things to execute a command, right? So I have summarized the most important data wrangling processes and tasks that will be used with Python. So with the Python toolboxes, we can do these 7 types of data wrangling processes. So the first one is reading, second one is selecting, third one is filtering, sorting, grouping, rearranging, and ranking. So it's easy to remember them. So you have 7: reading, selecting, filtering, sorting, grouping, rearranging, and ranking. So when we think about reading, it's sort of not only reading a file from Excel or CSV, it is about kind of reading parts of it. You can read the head, tail, and also describe will give you the kind of a summary of the data. And then when we think about selecting, you can select column wise. Now I restrain from using the word columns because we are talking about multi-dimensional arrays. It's difficult to imagine what is a column in a multi-dimensional array because it's very convoluted in that sense. So selecting a particular variable name in the multi-dimensional array, data belonging to that, or a range, that is df n1 to n2 means if you have these two are integer numbers, so you can get a range out of it, and df particular range plus a particular variable section. So it's like you have 2 variables and 2 different one range, so you can extract data like that. And filtering, of course, you are familiar with filtering in R. It's like filtering out variable data values that are greater or smaller than certain thing, or some other condition. Sorting, of course, is easy to understand, ascending or descending order. Grouping means you have to cluster the data. Rearranging, you arrange the data in the way that you like, the way that you want. And ranking is also an ordinal way of data wrangling. If you have several different ways of organizing data, of course, you can follow that. Right. So, right. That being said, I hope that is easy to understand at the moment. Again, I'll go to this aggregation part. Aggregation is summarizing data of a given column or a given, again, restrain from using that given axis. So axis is the correct word because you might have different axes. So you can use these aggregation functions to generate summaries along a certain axis. So if you say count a certain set of numbers, it will create the number of non-null observations, and sum is giving the sum of course, mean, median, minimum, maximum, product of values, standard deviation, and unbiased variance. So again, I refrain from talking about these statistical terms and these descriptors or descriptive statistics or whatever you call it, because you learn it under DA 1110 or 10 something in the first semester or second semester about probability and statistics. So, and again, you learn these things in probability and statistics too as well. So I'm not going to talk about those things again. Refer to those notes and try to memorize or kind of recall what is happening. Okay, right. For those who are now, I think you are familiar with what is the whole picture of this one. Now, that is part of the theory. So now you might have a question like how it is assessed in this course. How am I going to give you questions, or how am I going to assess your knowledge in the subject? So I'm going to assess your knowledge under 3 main ways. So those who are using note or taking a note, you can have a note. So these 3 ways, I'm going to assess your knowledge about the programming parts. So basically, how do you write a programming sequence or code? I am going to assess that. So without any syntax errors. So that's the first one. The second thing I'm going to assess in you is the logic behind it. So there will be complex sequences like take the, if I in words, I can tell you that I want to know which age group is more prone to certain allergy or something. This is my problem statement. So you should be aware of how to wrangle data from a given data set in a way that you capture that data. So you kind of single out that data set from a given set of data. So in order to do that, you might need to first assess what is the maximum, minimum, what is the average, and also aggregate on count non-null values, and you have to perform the logic behind it. How do you do that? So I'm going to assess that part as well. And the third thing that I'm going to assess in your assessments mainly is how do you optimize that wrangling process. So because sometimes if I ask you to select people who are in the age group of 25 to 30, some of you might be doing a task that contains choosing people who are less than 25, choosing people who are greater than 30, and then removing them from the set as a set operation from the total set. So that is a three-way logic, a three-way process. And some of you might be just simply extracting the data from 25 to 30 range. So that's a single process. So in terms of data wrangling, if your process is not optimized, then it will consume a lot of computational power. Therefore, I'm going to assess the optimization capabilities of your logics and your programming. So it is important that when I give you these exercises, you follow what is there and then just do it. I'm asking you to upload because I want you to follow these codes. And then when I give you a task, I am asking you to prepare a, say, 4 pages report on how did you do that data wrangling task. Then I'm going to give assess the marks, assess your assignments based on that, on those three facets, three things that I have mentioned. Okay, so be noted that. Now for this one, you can get this data wrangling Python sheet, Python part 1. I have structured this one based on 5 aspects. So the first one is filtering and selecting data. So as I've already told you in the lecture note, treating missing values, removing duplicates, concatenating and transforming data, and grouping and data aggregation. So first of all, before I go into the Honda environment and or rather Jupyter notebooks and show this one, I'm going to go through the whole note and show you what is happening. So the segment 1 here is filtering and selecting data. So as I told you, we are going to use the NumPy Pandas libraries here. Not because we are not doing any machine learning, we didn't use Scikit-Learn here, and also we don't do any scientific computing. We don't use SciPy here. As you know, SciPy also was built upon NumPy and Matplotlib. So Matplotlib is used for visualization. Here I'm not going to do any visualization, therefore I didn't import Matplotlib, but I did import NumPy and Pandas. And while I do that, you can see importing NumPy as NP is the working title for NumPy. So it's kind of abbreviation for NumPy in our working environment. When we do that, it's easy to call upon the other functions that are related to NumPy rather than typing NumPy dot something. It's easy to type NP dot. And for the pandas, it's important to do it that way as well, PD dot. Now, some of the students that I have taught these courses before have asked me, do we need to exactly say NP or PD? Why can't we just use another thing like X or C or whatever? Yes, it is possible. So when you do that one upfront, NumPy as say whatever the name you want, and also pandas whatever the name you want, you can do that, and you need to carry on the whole thing. But the thing is, as I told you, the Python environments, Python community, it's versatile. So you may have a lot of people who are working in this area, and you might need to get the um, at expertise. You need to get advice from somebody. Then if you want to show the code, it's very important that you follow the conventional approaches when you are typing. So NP is kind of a known thing for NumPy. Pandas is kind of an industry norm for Pandas PD. So it's important that you follow these conventions when you are developing the codes, because it will always help you referring, and also somebody who's going to get your help will also be benefited if you follow the conventions, right? Now I have opened up other things. Now selecting and retrieving data, you can write an index value in two forms: label index or integer index. Label index means it's like kind of a dictionary, and integer index is something that you already know. So series object, I have now, I'm going with very basics here. You have left side, on your left side here, series obj is a variable name, and this is the assignment. To the right, we do the assignment. So it's a series of numpy arrange 8 and index row 1 2 3 4 5 6 7 8. So when we execute this one, you should be getting a series object. So let's try doing that. I have created the whole thing to save time. So I'm going to import numpy. So shift enter for Mac, it works. And then I'm going to shift enter. And as you can see, what do we have here? np.arrange 8. So you have 8 values starting from 0 to 7, because you know Python starts with 0. When you count 0 to 7, that is 8 numbers. And index have been given, it has been given as row 1 2 3 4 all the way up to 8. So if I change a value here, let's say row x something, and then when we play, you can see it is here. So if you find any problems related to this one, or you have some issues, always play with the code and see what happens. So if I say 9 here, as you can see, it gives you a length passed value is 9, index implies 8. So for me, when I learn Python, like you, in my undergraduate days, and of course when I do research, if I find a mistake, if I find some code to be correct, what I do is I change the code and see what the error message I get. So here, when I change it to 9, I get an error message saying race value error, length of pass value is something, it implies that is different from what is given. So when I say 8, it works. 9, it doesn't work. When I say 7, it also give you that index doesn't match the created numbers. So try playing with the code and learn. So the second one, I created the series object. Now I am executing this code. So what do you expect this code to do? As you can see, we have created a series object with these rows. And now I am extracting data. I'm selecting data where the heading or the index is row 7. So I should get number 6 here. As you can see, I get number 6. If I say X here, I don't get, because it's a key error. It shows as a key error for row X. There is no key with a number X. Now, if I type X here and execute this one here, you will get value for row X. So likewise, it's a continuation of the logic and the order in which you have used it. Therefore, it's very important that you try to play with back and forth with the code, because when I give code, some of the students might think that it's easy to copy and paste, and why do we bother? But I give it in an order that that you can use that code to learn many things. So now not like the hard and fast way. You can't learn programming if you don't play with the code. Right. Now, when I say a series object 0 and 7, you can get row 1 and now this is a list within a list. So if I say another value, you can see that the index value is changed. So if I get a different value, so you get a -1. So let's see what happens here. So as you can see, why this happens, I might ask why this happens. So that is not included in the syllabus, right? So these are the things that I ask in your quizzes. Therefore, don't expect that it's going to be something like a very straightforward thing. It's the same thing that you learn, but what I ask will be, if I type this, what will I get, something like that. Okay, so have to be very cautious when you do that. Now I have these things, and in every case I have explained the things along with it. Now series object, list within list. When I select 0 and 7, you get row 1 as 0 and row 8 as 7. So this is the thing, and you get the data type as well. And on the second, in this cell, I have created np random seed 25. So np.random will create random numbers, 25 random numbers, and I'm creating a data frame object. So that is data frame. So where did I get this data frame? I have imported from Pandas that I need a data frame. So data frame object, data frame, np random number 36, reshape that to 6 by 6. So this is an entirely single code which contains several things. So np.random creates random numbers 36, and then reshaping it to 6 by 6 column and row data frame. So this data frame should contain 6 by 6. Index values are row 1, row 2, row 3, all the way 6, and columns, column 1 to column 6. So you can see that it's a 2D array. With the left hand side, you will have row 1, row 2, row 3, and on the column headings, you have column 1, 2, 3. So you have 6 by 6. And what do we have? 6, 1, 2, 3, 4, 6 columns, and so 6 index values and 6 columns will give us 12, right? So 6 by 6 is 36. 36 minus 12. Let's see what will happen. So as you can see, the np.random seed, let's say that I make this one a comment. It will work. It will still work, right? So let's say that if I make this one, it will not work because you have to have that order. So this is just a just to show that you can generate random numbers 25. So you can actually, my question in your exams or whatever will be, think about it. I might ask you giving a different number here. Say if it is 81, if this is 81, you have to reshape it to be 9 by 9, because 9 times 9 is 81. And then you have to give a few more names. So I have 6 already. So I'm going to give just a bunch of new names here. And I'm just going to put that same thing here. And then let's execute it. So you get the same thing, some random numbers in a data frame with row numbers and column numbers. So I'm going to remove them just in case, because I might use this one for your next batch as well. Until then, I might not touch it. So I just remove it here. And this is 36. And this is 6. 6. Right. So the same thing. Now, that's how you create it. Now I have created the data set. Now I'm going to it's a part of data filtering and data selecting, because I created this one. I have this data frame object now. I'm trying to locate the data that contains row 2 and row 5, column 5 and column 2. So before executing it, please try to understand what happens here. I want XY sort of a thing. So I have row 2 and row 5. So it should be this one, row 2 and row 5. So this one, I need these 2 rows, but I have restrained it along the columns as well. I need this column 5 and column 2. So which means I'm going to get 4 data points that contain this one and that one. Right? Let's execute and see. As I told you, it's going to be like kind of a convoluted to that 4 for those four data sets. So that is why I say if you are thinking about a multidimensional array, you might need to understand how the multi-dimensions occur inside the data frame. So you might have to think in 3D, 4D. Sometimes you don't get that impression, but you need to understand how the data points have been distributed. Right. So this is how you select it. Now, when it comes to data slicing, you can use slicing to select and return a slice of several values from a data set. Slicing uses index values, so you can use the same square brackets when doing data slicing. How slicing differs, however, is that with slicing, you pass in two index values that are separated by a colon. So here, as you can see, I just separately give two different key values, right, index values. But in the case of data slicing, what we do is we kind of create from row 3 to row 7. If I execute this one, I'm getting row 3 to row 7. I can even say row 4 to row 7. So it all depends on what you really want. So it slices the whole set based on the series object. Now, this is the series object. Okay, don't get confused. It's not a data frame object. It's the series object that I have created for these things. Now, if you want to check that one, the good thing would be try putting DFB object and see what happens. So I have row 2 and let's see what happens. See, it executes that and it gives you the values that you like. See, so it doesn't matter. So it gives you the slides, right? So I changed it. I'll keep it that way. So if you want it, you can check with the series object because it's a 2D simple one. I just kept it as is, but this is more like a data frame object. So I sliced it using the two values. So it's your task to check whether you can do it in this way as well, like this case. Now, for the object, I have, can I give this slice? And I want these columns only. So if I want it, can I do it like this? Can I do it this way? Like I can make this one inside one list, right? And then can I do the other way around, like comma and this, and instead of rows, if I type this, whether it's going to work. You need to do it and see how it works. Say column 5, column 6, it doesn't work, invalid syntax. Then you have to check whether this works, right? So that's how you learn. It doesn't work. So then what is the way to select the rows and columns you want? You have to select that. You have to learn and see how it works, because everything cannot be taught in a lecture, right? So, right. So that's about data slicing. Now, when we go to comparing with scalars, now we are going to talk about comparison operators and scalar values. Just in case you don't know what a scalar value is, it's basically just a single numerical value. You can use comparison operators like greater than or less than to return true or false values for all records to indicate how each element compares to a scalar value. So when you type this one and enter, you can kind of see true or false. Now let's see, can we do this one, right? Because now that's the beauty of programming. See, I just simply extracted the data values from the data frame object, just simply using the logic. So what did I get? If I say Control Z, sorry. This is initially, it's a logical sequence which gives me row and column with true or false. So I use the logical array, right? I use this logical sequence to extract data from the table itself. Then with the future things that you want to do, maybe you extract the values from this one, you can continue. So I request you to do these kind of things and check whether that is possible, and take a piece of paper and write down that you can do it. That's very important. That's how you learn. And then filtering with scalars. So I think I have already shown you how to do that. You can say a series object, that series object comes from here. So whatever that is greater than, you can just execute and see. Setting values with scalars. So you have the series object, these things to equal to 8, and you can see the values have been changed for the series object. So you can do the same thing with this one. So then what you should do, you should try to see whether my previous thing works here as well. So that is what you call yourself learning. So if I were you, what I would do is, I will see, now I know that this works, right? So this works. Then I'm going to say this is equal to 8 and see whether that's going to work. It should work. See, all the data points have been changed to 8. So it's very important that you try to learn it while you do it. So what did I do here? I used the logic that I can use the slices comparison and slice the data, and I made the data equal to something, setting values here. So it may be more of a high-end stuff, but when you do that, you kind of understand how to do things. Filtering and selecting using pandas is one of the most fundamental things you will do in data analysis. Make sure you know how to use indexing to select and retrieve records, because that is the way you handle data. As I told you, you can actually select certain set of data for your analysis. Say that people with the height greater than 130 centimeters, people with the weight less than 50 kilograms, maybe the distance from your home to the university. So selecting data, these applications are more important than any other analysis that you will be learning in the entire course, because the analyst job fundamentally comes with trying to understand your data. So it's very important to learn how to wrangle and how to do intelligent wrangling with optimization, and this leads to hacking as well if you are more into those stuff. Now, that being said, we move to the treating missing values part. Now, you will find a lot of missing data. Now, if you give a certain set of people to give you, like in the case of your own case, now I have what? How many missing assignments here? So if I automate the process to mark, I will have what? 8 missing submissions already. So this is the type of thing you say missing data value. So I have 8 missing submissions here. So if you are trying to get the submitted assignments list, you'll have missing values, 88 missing values in my case. Now, how to deal with those missing data? You either need to select them or you need to discard them. So figuring out what data is missing is the first step. I'm going to create a NaN values or not a number set. So this is an np.nan means numpy, not a number. So I call that not a number as missing, right? So this npnan is missing, right? That's assigning this name missing to, or rather npnan to missing. So I put missing. When I say missing, it's a missing np.nan, right? So I create this object, and this is how it looks. You have a series object, you have the index values, and then you have the numbers, row 1, row 2, and then you have this missing value. So nan is a not a number, not a number. So that means it is missing. So is null will give you the logic. So it's like greater than, equal to, or less than or equal to. So it's a logic. So you are applying that logic on a data frame object and asking whether it's is null. So it will give you false or true. So again, following my notorious work, I can see whether it's going to give me the not null set, and doing that, I get this, right? So as you can see, I can also check whether is a not logic work here. Yeah, it doesn't work here. So I don't know, you can check that out and see how to apply the how to select a non-value, right? Sorry, non-null objects in a set. So it's quite interesting, right? So series object. So if I say something like that, will it work? Yes. So that means I can do the same, and in this case I use the not logic and it doesn't work. So series of it works. So this is the way to select non-null values. So as you can see, I myself don't know some of the things, but I learn by doing it. And when I do it, sometimes it might look like very complex, but it's very simple. I just play with the code. So series object is null will give you false or true, a logical array. So I use the logic and use the not logic here in front of it to make it true. So false values will become true here, and I use that true thing to get the series object out of it. So play with that. So those kind of things are the fun stuff. So yeah, so is null will give you n values. Then filling in for missing values. If you again we go the random seed and random create tree shape, and then this is the data frame object. So in this case, I haven't renamed the columns and rows and columns. But in the previous case, you remember we named the rows and columns and row 1 and row 6 and etc. So then what now remember, now this is very important, this missing doesn't mean anything. It doesn't mean anything unless you have already said that missing means np.nan, right? That is very important, because some of the students when they learn this one, they think missing means none, or whatever the variable I have used here will be that thing. No, I have to assign that numpy.nan, not a number, is some variable. It can be x, it can be zero, invert 0, z or something. That thing is missing. So when I say missing, this means np.nan, right? So I have assigned the locations of 3 to 5, slicing that to this missing, and this is what we get. So from 3 to 5, so 3 to 5, 0 is missing. So 3 to 5 in the 0th column is missing. This is missing. And 1 to 4 in 5th column is missing. So that's how you read it. So location, this is row, this is column, row, column. So row, this range, column is missing. Row, this range, column, this is missing, right? So it has none, not a number. Now fill this not the number values with a 0. So very simple to remember, fill NA. So what is the is null means whether it's a null value, fill NA means fill not a number thing, and NaN is just not a number. So what I do is I create the data frame object, and I purposefully gave this not a number thing, and I'm going to fill that not a number with 0. So what are you expecting here? You should expect that NaNs should be 0. So they become 0. Why this is important? Now, this is very important when you are dealing with machine learning. So it's a very important thing to remove the missing numbers or missing values, because you don't know what error you will be looking at, because some of your data sets might be missing values, right? So first you need to identify the data types, whether it's a floating number or an integer or a text value or string or whatever. So first you identify that, identify the null values, and then you have to fill those values. Then only the machine learning data or machine learning algorithm will identify that it's a missing value. There are ways that you can indicate that it's a missing value. But when you use a number like number or a condition or something, then you can easily remove those values. You can remove that using is null as well, but that is going to be complicated in some cases where some algorithms are going to give you values closer to 0, right? So it's very important. Okay, so sometimes some logics that are like how to say, constructed logic, that nested logic, some nested logics might give you NaNs, like dividing by 0. Those things are pretty much all in the card. So you don't know what values are missing. Therefore, you can't really say that is null, or you have to always look for where the missing values are and how these operations get halted. So in this case, fill NA will give you 0. Right, fill data frames, the data frame object, fill NA. Now, as you can see now here, fill the missing values with 0. But here, fill the missing values with 0 to 0.1, then 5 to 1.25. Let's see what happens here. Observe that. So 0 to 0.1, right? So 0 to 0.1 is here, and 5 to 1.25 is here. So as you can see, the column, depending on the column, the fill value has changed as well. Right, so this one is again fill is a method. So you can learn about that one with long discussion to discuss about that one here. Then you have the counting missing values. You have missing values, as I have given earlier. I have indicated that these values are missing, and this is the now you have NaNs. Is null sum. So basically the same thing. Count of the matrix where you have this number of NaNs. So in the case of 0 column, you have 3, and 5th column you have 4. So that's what it has indicated, is null. Then you have the data frame objects. Drop NA means, again, as I told you, it's very important in machine learning to remove those null values. You can drop NA. So drop NA will remove those values. As you can see, now this is quite a revelation, because you can see that when you drop NA, a lot of data is going to be removed, because at least one N is going to remove that thing, entire thing. So you will have only one. So that's why I told you sometimes you will collect thousands of data, and even one single NaN will be useless. So if you don't do the processing, wrangling part earlier, then probably you are going to miss a lot of or rather you are going to exhaust your resources in finding something that is not there. So you have to remove the NaNs before analysis. So that's how you do it, dropping NAs. And this one is very, very nice. Now, I told you about axis. Now, here, drop NA on axis 1. Let's see what happens. Cool. So here, what is axis 1 here? You can see that when you think about axis 1, it has taken the in one direction. So drop in one and taken on the other. Let's see whether we can change this one to 0. What will happen? Can we change it to 2? What will happen? See, so 0 indicates one axis, and 1 indicates another axis. So if you say 0, you will be dropping all the NNAs in this direction to the right side, your x-axis. So axis 0 is x-axis. Axis 1, I mean, it's not the kind of the x or y, okay? Because you can have multi-dimensional arrays. So in that case, different axis, like you can have axis 4 as well, axis 5, 6, 7 also. So I'm not talking about that. I'm just giving you how to understand this one here in this case. Okay. So axis 0 is like from your left to right. So when you say axis 0, it allows you to drop anything that has NaN on the left to right direction. If I say axis 1 here, it indicates like the y-axis. So if you have like from top to bottom, so if you have any value that is missing from top to bottom, you will have only that you will remove that. So here you have this column having it, this column having it. So you have only 1 to 4 here. So understand that one. Okay. So this is 0 means it's only single row because all the other rows have NaNs in between here and there. Okay. So when I say axis 1, I just leave it here. You have the y-axis. Now we are pretty much near the end of the lecture. When we talk about removing duplicates, you can import these things again if you are doing this one as a fresh thing. But I have already imported these things above, therefore I don't need to import them again. So I just made them commented. Now removing duplicates is also a big problem if you are working with data that contains, say, your index numbers are also very annoying because sometimes I find your index numbers in this subject, that subject, this assignment, that assignment, but they are all same, right? So sometimes it's important to remove them when you are trying to understand just one point of it. You can remove that duplicates and just keep one. That's it. So removing duplicates is also something important. Now I have created a data frame. This is like a dictionary. So column 1 contains these values, column 2 contains these values, etc. So what is your expectation here? You are going to expect that a data frame object with columns, column 1 and 2 and 3, and with the values that are given here. So observe that in such a case, you will always have same number of data points in each of the list. Otherwise, it's going to be difficult. Now, before executing this one, let me remove this one. I'm going to remove this one and execute it. You can see that it's not going to work because this dictionary doesn't have the same amount of data points along those columns. So I have to again put that C here. Then only it will execute. Okay, because now it can create this data frame object. So what do you learn here? You learn that you need to have equal amounts of data points here. Let's say that I put a missing here. What will happen? So you have an NA in here, still you get a data frame object. So sometimes when you are dealing with machine learning, you need to have the kernel as the same kernel. So sometimes you have to fill in with missing values or some sort of a thing to just make sure that you have the data frame object. Otherwise, it's not going to create it. So that's a very important observation. Okay, so I created this with the duplicate column here. So CCC and BBB. If you remember, these kind of things are generated by tidyverse as well in R. So you have this as well here. So I'm just going to check whether there are duplicated items. So what are you going to expect? So if you have followed the logic here, I'm going to expect a logical array. So I'm expecting a logical array and I'm getting a logical array as well. So index values 0, I don't have any repeating stuff. Row 1, I don't I have repetitions because it's 1 0 A. Row is repeating. So why am I considering the row? It's because if you remember, like I'm now parallel talking about the machine learning. In machine learning, a row is an instance. So if you have an identical instance, it's a repetition. So it's a duplicate. It's like having, say, you are a girl, age of 25, you like ice cream, and you are, say, you are in a relationship or something, and then you have the same instance. So it's a repetition of that data. It may be somebody else. So if it is somebody else, we need to have another key that indicates this, and this is another person. Then only we'll get the name. So in the name also, one will be, some, I am going to get a name something like Rochelle, and the other one is also Rochelle. So if the names are the same, again it's a duplicate. That's why we are going for index or some other unique numbering system, so that we get the same instances. But if they are the same, we are going to get this duplicate as a true. Okay, so in this case, duplicated, yes, it's a Boolean type thing. So when I drop duplicates, I am expecting to have unique instances in my data frame. So that means I will have 0. So all these false ones, I'm expecting all these false rows. So sorry. So you have 3 false. So I expect you are getting 3 columns that are unique. Okay, this is very important also, to get the unique values, to get the unique instances. Sometimes it's you will get a data set that has so many duplicates. So you have to get the unique values. So this is how you kind of do it. Okay. So again, we have it. Now, again, something that I need to remind you, the Python thing, this entire thing works like in machine learning. So in machine learning, I told you that the row is an instance. So if that is the case, then it looks at the data set from left to right. But in the case you want a column, then you have to specify the column. So you get this column A, B, C, D. So A, B, C, D, because A, B, C, and they are repeating. So it removes that and gives you the sorry, it gives you the unique set of data rather than the duplicates. So this is important because sometimes, as I told you, there will be many Rochelles, but somebody might like ice cream and somebody might like chocolate. So if you drop the duplicates, you might find 2 Rochelles who like one like ice cream and one likes chocolate. So this type of a arrangement is also very important when you are trying to feed a system to analyze a certain thing that you want, right? That's about it. Okay, so since the other parts, I am, one thing is I thought it's very unfair that we have only 4 students and I'm just like kind of recording this one. Let's make it short here. I'll talk about the transformation and grouping and data aggregation with more elaborated example and kind of a project sort of a thing, and explain that in the next lecture when we meet on no 21st lecture. Hopefully will be about text mining, because I have some plans. I'm working on this higher education committee or something, not a committee, higher education, what do you call that, education improvement something. So I have to work with you on some interesting task in text mining in R. So I will be doing that next week. Hopefully, I hope that people will participate in the lecture. Please ask your friends, if possible, to be present. I mean, if possible means if you have electricity and all, please, and internet or something, just be present there, because I need people. I need at least 20 odd group. So I'm going to do that, but definitely I will update you on this one. And Python data wrangling is very important, and that's why I'm emphasizing on that. So follow along, sorry, the exercise files, and please upload this one, which you find as a PDF file. Take it and copy paste this one, and try to play with it, and then upload the PDF file with your index number. How do we do that? You just do the exercise here. You create an Python Jupyter notebook and do the exercise, do the same thing that I have uploaded, and then you can download as a PDF, yeah, download as a PDF, whatever HTML or PDF, whatever thing, PDF, and then upload it. I'll create a link, upload it to the Moodle, just to make sure that you have followed everything. And here I'll upload this data set, the data, empty cast CSV data file. It's in my computer. So I'll upload this to the Moodle, the link to the data set here. So just download that one and save it in your library, and then execute this address based on your library, and then do this one. Just upload the PDF to the Moodle. That's all. And then I'll give you, once I complete this task, I'll give you data wrangling in Python, individual and group work. The group work will be a bit challenging. Individual task will be more like giving you a data set and asking you to do a certain data selection. That's all, right? So please ask your friends to always refer to the Moodle, because I know that it is very difficult for everybody. So I want to make sure that everybody gets the same amount of data and the learning materials and everything equally, so that nobody is left behind. So if somebody has issues, ask them to share that with me, and then I'll try to adhere to that within the boundaries that I am restrained. Okay. So thank you for staying in the lecture. I'll upload the recording. Please ask your friends to go through and upload the exercise files as PDFs to the Moodle. All right. So I'm going to stop.